Hi, we're looking at how to simplify rational expressions today. We're going to take expressions like you have here on the left and learn how to simplify them into what we have here on the right. Okay, much simpler version of this. So if you want to learn how to do that, let's keep watching. The very first important technique we want to learn is how to cancel out common factors. And this is what we've been using for quite a while when learning how to simplify rational numbers. So for example, if you have a rational number like 6/4, how can we simplify this? Well, the answer is you want to sort of factor out, take out the greatest common factor of both the top and the bottom, and then try and cancel that out. So we can imagine 6 is the same as the product of 3 times 2. So 3 and 2, these are both factors of 6. And then here, 4 we can think of as 2 times 2, right? These are the factors of 4. Now you see we can cancel out a 2 from both the top and the bottom, leaving us with 3/2. All right, there you go. So we've canceled out the greatest common factor of both the numerator and the denominator, thus simplifying this fraction. Now let's do it with a rational expression. Okay, so here we've got a rational expression, and we're going to do the same exact thing. So in the numerator, I am going to now factor out an x. I can factor out an x, and that will leave me with an x squared plus an x plus a 1, right? So I've taken out the greatest common factor of each of these 3 terms. And of course, in the denominator now, I still have my x, and now I can cancel that out. I can cancel out an x from the top and the bottom, thus leaving me with the simplified form of this rational expression. It's just x squared plus x plus 1. All right, so there we go. That's how we can simplify this rational expression by canceling out sort of the greatest common factor of the top and the bottom, just like that. Now, the problem is we've kind of lost a little bit of information after simplifying here because we need to consider the domain. Never forget the domain. Okay, so what is the domain of this rational expression? Well, when we look at this, it seems like it could be any real number, right? I can plug in any real number for x and I'll get a number out. But this is not what we started with. We started out with this, and there is an x here in the denominator. And I know the denominator cannot equal 0. So that's telling me x cannot be 0. So my domain will be any x such that x is not equal to 0. And so we have to just try and remember the domain. Okay, so go back to the original expression in order to recover that information about the domain that might have been lost when you simplify it. Let's take a look at another example. All right, here I have another rational expression, and at first glance you might be tempted to try and sort of cancel out an x squared from the top and bottom, but we can't actually do that because if you look at this numerator, x squared is only in the first term. It's not present in the second term. There's no x squared here for me to factor out. Same thing in the denominator. There's no x squared in the second or third term. So x squared is not a common factor of either the top or bottom. We have to figure out another way to factor this. And since these are both quadratic polynomials, we already know some techniques to do that. So let's try and factor this numerator first, this 4x squared minus 9. I'm going to write this as 2x, let me write that a little better, 2x squared minus 3 squared. And when I write it that way, it should be pretty clear. This is a difference of 2 squares structure here. So I can write this as a 2x plus 3 times a 2x minus 3. And so now actually this is the factored form of my numerator. I also want to do the same thing now with my denominator. How can I factor this expression? Well, this polynomial is not quite as straightforward. I'm going to use the AC method where I multiply my value for A and C. So 2 times -3, that's going to give me a -6. And then I see here for my B value, I have a -1. Okay, so the whole idea is I need to find the factors of -6 that sum together to give me -1. So what are the possible factors of -6? Well, there's -1, 6, -2, and 3, and then I can negate this, right? So I also have a 1 and a -6, a 2 and a -3. And I need to see which of these work, all right? So if I add -1 and 6, I'll get a 5. Adding -2 and 3, I'll get a 1. Adding 1 and -6, I'll get a -5, and 2 minus 3 will give me a -1. So clearly now, this is the combination I want. This gives me my -1 right here. So I am going to write down this denominator here as 2x squared, and then I'm going to have the 2 and the -3. I'm going to sort of factor by grouping later on. So I'm going to split this -x into a plus 2x, and then a minus 3x, and then a minus 3. Okay, so that's what I've done. So I've essentially taken this -x and I've split it into a 2x and a minus 3x. Now from here, I can factor by grouping. I have to make my groups. Okay, so I'll write this as a 2x squared plus 2x plus a -3x minus 3, just like that. So I've just made some little groups. And now I'm going to factor out some common factors here. I can factor out a 2x. That'll leave me with an x plus 1. And over here I can factor out a -3. So that'll give me a -3 times an x plus 1. And now I factor out my x plus 1 from both of these. And so that gives me then an x plus 1 times a 2x minus 3. Okay, so there we go. I have successfully factored my denominator using the AC method, factoring by grouping. So I've got a numerator and I've got a denominator, and now I can just simplify them. So let me do that. All right, so let's grab this numerator and then let's grab this denominator. And there we go. That's my new rational expression. We can see we actually have a common factor of 2x minus 3. So my final result here is going to be this 2x minus 3 over x plus 1. Oh, let me do that in orange. Okay, there we go. So that's my simplified version of this expression. I need to recall the domain. Okay, so don't forget about the domain here. So what is my domain going to be? Well, you might just think x cannot be -1. Okay, if x was -1, I'd get a 0 there. But we actually have to recall that's not what I had originally in my rational expression. So instead, what values here would give me a 0 for this denominator? I'm going to look at this factored form of my denominator, or I can just look at this one. So the x plus 1 means I cannot have a -1 for x, and this tells me that 2x minus 3 cannot be 0, which means that 2x cannot be 3, which means that x cannot be 3/2. Okay, so 3/2 is the other value here that I cannot have. So the domain will be any x such that x is not equal to -1 and x is not equal to 3/2. Okay, so now this is the actual domain for this rational function. So don't forget the domain, right? You're going to factor the top and bottom out, cancel out the greatest common factors from each of those, and then don't forget the domain, okay? All right, we've got another rational expression here, and it looks a little complicated, but actually, I can factor out a common factor from all of the terms in the numerator and then also from the denominator. I can factor out a 5. Okay, so if you recognize that, I'm going to factor out a 5. I'll get a 3x squared plus a 5x plus a 2. And in the denominator, I can also factor out a 5, leaving me with a 9x squared plus a 12x plus a 4. Okay, so not too bad. I've already done some good simplification. What I want to do is now I can cancel out this 5. Okay, so there we go. Now I want to factor the numerator here. Okay, so I'm going to use the AC method. So I'm going to take a times c, that's 3 times 2, that's a 6. And then I need to find the common factors of that sum to 5. That's my b value right here. Okay, so this isn't so bad. We've done this before. Factors of 6 are 1 and 6, 2 and 3. And clearly, I need to use 2 and 3, right? That's going to add to give me my 5. So now why don't I use, I'll use the box method. Okay, so I'll use the box method for this. So for the box method, we're going to take this 3x squared and write it here. Then we're going to take this 2 and we're going to write it here. And then in these two corners here, we're going to essentially take this 5x and split it. We're going to split it into a 2x and a 3x. And it doesn't really matter which one you write. So I'll write my 2x here and my 3x here. And then the whole idea is you want to take out the greatest common factor of each row and each column. Okay, so for this row, the greatest common factor, well, that's just an x. And for this row, there's nothing really there. I can just factor out a 1. That's as big as it gets, right? Now for this column here, I can factor out a 3x, can't I? Right? And for this column, I can factor out a 2. That'll be the greatest common factor. So this gives me a factored form of 3x plus 2 times an x plus 1. Okay, so this is now actually the factored form of the numerator. Very useful. Now let's do the denominator. Okay, let's do the denominator here. Now this denominator, I'm going to rewrite this. And this 9x squared, I'm going to write that as a 3x quantity squared. Then I'm going to have a 12x and then a 2 squared. Okay, now this is looking like a perfect square trinomial to me. And if this is a perfect square trinomial, that means this middle term will equal 2 times the product of these two terms here. Is that true? Well, I think it is, right? This is a 3x quantity squared plus a 2 times 6, which is 2 times this 3x. Just like that. And so, yeah, this does work. So this is going to be a perfect square trinomial, which means I can factor this into a 3x plus 2 quantity squared. And that's what I'm going to get here for the factored form of the denominator. All right, so now what I can do is I can write this out. Let me write out my expression here. My rational expression is going to be some 3x plus 2. Oh, that's the numerator. Okay, that's the numerator. And then my denominator here will be my 3x plus 2 squared. And sure enough, I can factor out and cancel this 3x plus 2 in the top and in the bottom. So that's going to give me my final simplified form of x plus 1 over 3x plus 2. There we go. Okay, that's the simplified form of this original expression. But of course, don't forget the domain. Okay, so for the domain, what will that be? Well, remember, this denominator was 3x plus 2 quantity squared. So whenever that's 0, we have a problem. When is that going to be 0? Well, that'll be 0 if 3x plus 2 is 0. So we're saying this cannot be equal to 0. That means 3x cannot be equal to negative 2. And that means x cannot be equal to negative 2/3. Okay, so that is my exception here. So my domain is going to be any x such that x is not equal to negative 2/3. And that's it. That's going to be the domain of this rational expression. Okay, so there we go. Hopefully this helped explain how to simplify rational expressions. We're treating them as a fraction, right? So sort of factor out the numerator and the denominator as fully as you can and see if you can cancel out any common factors. After you've done that, don't forget the domain, because the domain must refer back to the original expression, and the denominator cannot be equal to 0. So just find out whenever that happens, and that's when you know where your domain is going to be restricted. Okay, come back next time. We'll continue to learn more about rational expressions.